What is the integral of the square root of 1 plus x over 1 minus x? The first thing we need to do is multiply both the numerator and denominator of the expression inside the square root by 1 plus x. Once we do that, the integrand becomes square root of 1 plus x all squared over 1 minus x squared. Let's consider what the domain of the original function is for a moment, because this will be very important for simplifying the integrand we have at the moment. The expression inside the square root in the original integrand is 1 plus x over 1 minus x, and since we are only considering the integral in the real numbers, this means the 1 plus x over 1 minus x has to be greater than or equal to 0 for square root of 1 plus x over 1 minus x to be defined. If we solve the inequality 1 plus x over 1 minus x greater than or equal to 0, we end up with negative 1 less than or equal to x less than or equal to 1. Since the denominator of the fraction is 1 minus x, and the denominator can't be 0 because we can't divide by 0, we can infer that 1 minus x is not equal to 0. This implies x is not equal to 1. We also multiplied the fraction by 1 plus x over 1 plus x to get the third expression, so 1 plus x can't equal 0 because we can't have 0 in the denominator. So this implies x is not equal to negative 1. Keep in mind that this latest restriction only applies to the second and third expressions, because this came from the fact that we multiplied 1 plus x over 1 plus x. So if we put all of the restrictions together, we get the constraint negative 1 less than x less than 1. This implies that 1 plus x is in between 0 and 2 non-inclusive if we add 1 to all parts of the inequality. And we can also conclude that 0 is less than 1 minus x squared, which is less than or equal to 1. And to be clear, I am saying that this restriction applies to the third expression, square root of 1 plus x all squared over 1 minus x squared. Well, technically it applies to the second and third expressions, but I'll focus on the third expression since it's more simplified. This does mean we are losing the single point x equals negative 1 in the domain of the function when we multiply 1 plus x over 1 plus x, which results in the additional constraint that x is not equal to negative 1, but that doesn't matter for integration because we are only removing a single point from the domain. You can think of this intuitively as a single point not contributing any area to the integral. So if we find an integral for this new function with x equals negative 1 removed from the domain, it will still be valid for the original function square root of 1 plus x over 1 minus x. Let's look at the expression square root of 1 plus x all squared over 1 minus x squared for a moment. 1 plus x all squared is non-negative since the square of any real number is non-negative, and 1 minus x squared is also positive since 0 is less than 1 minus x squared, which is less than or equal to 1. Which we just worked out. This means we can apply the rule square root of a over square root of b equals square root of a over b when a is non-negative and b is strictly positive. This gives us the equivalent expression square root of 1 plus x all squared over square root of 1 minus x squared. Since 1 plus x is greater than 0, we can also use the property that square root of a squared equals a for all non-negative values of a to rewrite the numerator as 1 plus x instead of the square root of 1 plus x all squared. This turns the expression into 1 plus x over square root of 1 minus x squared, which is significantly easier to work with. So if we go back to the integral, we can rewrite the integrand as 1 plus x over square root of 1 minus x squared instead of square root of 1 plus x all squared over 1 minus x squared. We can first split the fraction and rewrite the integrand as 1 over the square root of 1 minus x squared plus x over the square root of 1 minus x squared. Then split the integral into a sum of two integrals. The integral of 1 over the square root of 1 minus x squared is simply arcsine of x, and that's just a standard integral, while the integral of x over square root of 1 minus x squared requires a bit more work. So to do the integral of x over the square root of 1 minus x squared, we need to first take the constant of negative 1/2 outside the integral, so the numerator becomes negative 2x. And the reason we want to do this is because the negative 2x is the derivative of the 1 minus x squared expression in the denominator, which means we can substitute u equals 1 minus x squared. If we do that, then du equals negative 2x, and the integral becomes the integral of 1 over the square root of u du, since negative 2x dx is replaced by du, and the square root of 1 minus x squared becomes the square root of u, since u equals 1 minus x squared. Of course, the constant of negative 1/2 outside of the integral stays the same. So if we apply the reverse power rule, the integral of 1 over the square root of u is 2 square root of u, and after we multiply by the constant of negative 1/2, we get negative square root of u. If we substitute the 1 minus x squared back in for the u, we get negative square root of 1 minus x squared. We also need to add the constant of integration c, but that's not really important at this point. So anyways, the integral of x over the square root of 1 minus x squared is negative square root of 1 minus x squared plus c. So if we go back to the main integral, we can rewrite the integral of x over the square root of 1 minus x squared as negative square root of 1 minus x squared, and we can just add a single constant of integration c at the end of the expression. So the integral of square root of 1 plus x over 1 minus x is arcsine of x minus the square root of 1 minus x squared plus c.